A single explosion crippled their spacecraft, stranding them in the void. Their mission was no longer the moon. Welcome to the channel. Today we explore one of history's most dramatic engineering failures. In 1970, deep in the void of space, the crew of a mission designated Apollo 13 faced a sudden and catastrophic event identified as an oxygen tank explosion. This single moment is officially documented as a major engineering disaster, a classification that speaks to the profound severity of the failure and the immense peril it represented for everyone involved. To be struck by a failure of this magnitude presented an unprecedented challenge, forcing a complete reevaluation of the mission and turning it into a desperate fight for survival. The foundational fact provided by the source material is that the Apollo 13 mission in the year 1970 suffered an oxygen tank explosion. This event is not described as a minor malfunction or an anomaly. It is explicitly and soberly classified as a major engineering disaster. This designation alone frames the incident as a critical failure of hardware and planning, a moment where the complex machinery of spaceflight broke down in the most dangerous way imaginable. The source focuses on this classification, establishing the gravity of the situation without providing a moment-by-moment account of the explosion itself. The source does not provide enough detail to construct a full narrative of what happened. There is no information regarding the specific time the incident occurred, the location of the spacecraft relative to the Earth or Moon, or the immediate verbal reactions and emergency procedures initiated by the astronauts and their ground support teams. The provided text serves only to identify the core event, the explosion of a single, vital component, and to label it as a significant engineering failure. All other specific details about the sequence of events remain entirely undocumented in this source. The source identifies the mission by its official designation, Apollo 13, and confirms the year of the incident as 1970. This places the event squarely within the timeline of humanity's ambitious initial voyages to the moon, a period of unprecedented technological achievement and national pride. The name Apollo itself carries the weight of that entire endeavor. However, the source provides no further context about the specific goals of this particular mission within the larger Apollo program, leaving it unstated whether it was intended to be the third lunar landing or if it had other scientific objectives. The source does not provide enough detail to answer these fundamental questions about the mission's purpose. The intended destination is not stated, nor are the names or roles of the astronauts who were tasked with this historic flight. The human element, the individuals who faced this major engineering disaster, is not present in the text. Consequently, while we know the name of the mission that was crippled by the oxygen tank explosion, the specific ambitions that were suddenly put in jeopardy and the identities of the crew members are not described in this particular document. In the analysis of any catastrophic failure, the search for preceding indicators is of paramount importance. The history of a component, including any subtle anomalies, overlooked test results, or prior issues with the hardware, is often the key to understanding its eventual failure. A complete picture would require access to manufacturing records, ground testing data, and any communications that hinted at a potential problem before the mission ever left Earth. What clues might have existed before the disaster unfolded? The source does not provide enough detail for this section. The provided text makes absolutely no mention of any pre-existing conditions, technical concerns, or anomalous readings that could be interpreted as a warning. The documentation focuses entirely on the singular event of the explosion and its classification, offering no insight into the life cycle of the specific oxygen tank that failed. Whether the disaster was a sudden, unpredictable event, or the culmination of a series of overlooked red flags is a question the source leaves completely unanswered, providing no trail of evidence to follow. The source text is direct in its identification of the failure, an oxygen tank explosion. This pinpoints the physical origin of the crisis to a specific life-sustaining piece of hardware within the Apollo spacecraft's service module. The text also includes a directive to research and describe the failure mechanism, which confirms that understanding the precise technical and physical processes of the explosion is central to understanding the event. How, in an environment of rigorous testing and triple redundancy, could such a critical component fail so violently? The source does not provide enough detail to describe the failure mechanism itself. While it names the component and the result, it offers no explanation of the underlying engineering causes. The document does not specify whether the failure was due to a design flaw, a manufacturing defect, a procedural error during maintenance on the ground, or damage sustained during the violent launch phase of the mission. The intricate chain of events at the technical level, the sequence of electrical shorts, overheating wires, and rapid pressure increases that culminated in the explosion, is not described in the provided text, leaving the why of the failure a complete mystery. The term major engineering disaster implies a severe and immediate aftermath, a cascade of secondary failures, and a life or death struggle for survival. Following the oxygen tank explosion, the consequences for the spacecraft's systems and its crew would have been immediate and profound. The loss of an oxygen tank meant not just a loss of breathable air, but also a loss of power and water, crippling the command module and turning the mission from one of exploration into one of pure survival. The response from the crew and mission control to this unprecedented crisis would define the mission's outcome. The source does not provide enough detail to describe the aftermath. There is no information about the condition of the astronauts, the status of the command and service modules, or the incredible story of ingenuity and perseverance that would have been necessary to overcome such a catastrophic failure. The text classifies the event as a disaster, but provides no account of the monumental rescue effort, the role of the lunar module as a lifeboat, or the perilous journey back to Earth. The entire human and technical drama that followed the explosion is left untold by this document. In the wake of any disaster within a government program like NASA, a formal and exhaustive investigation is inevitable. The source text itself implies this by stating a need to research the engineering background and failure mechanism of the Apollo 13 incident. A review board would have been assembled to meticulously dissect every piece of available data, from telemetry recordings to contractor manufacturing logs, in order to determine the precise root cause of the oxygen tank explosion. The goal is never just to understand what happened, but to ensure it never happens again. The source does not provide enough detail regarding any investigation findings. It does not name the investigating body, such as an official review board, nor does it present any of their conclusions. The specific chain of human error, design oversight, or procedural missteps that an investigation would have surely uncovered is not documented in the provided text. Therefore, the official explanation for why the tank exploded and who or what was deemed responsible for the major engineering disaster of 1970 remains unstated. A major engineering disaster in spaceflight does not happen in a vacuum. Its impact extends for decades, shaping the future of exploration. The source text prompts an examination of the lessons learned from the Apollo 13 oxygen tank explosion, indicating that the 1970 incident was a formative event for NASA. Such a near catastrophe would inevitably lead to sweeping changes in hardware design, testing protocols, and the very philosophy of mission planning and emergency response. How did this failure fundamentally alter the path of human spaceflight? The source does not provide enough detail to describe the legacy of Apollo 13 or the specific lessons learned. There is no mention of subsequent engineering modifications made to the Apollo spacecraft, no description of new safety procedures implemented for ground crews, and no discussion of how contingency planning evolved for future missions. While the event is framed as a significant disaster, its long-term impact on the space program and the concrete changes it spurred are not detailed in the provided document, leaving its ultimate contribution to the safety of future astronauts undefined. The source material concerning the Apollo 13 incident of 1970 provides a stark and powerful, if brief, summary. A major engineering disaster caused by an oxygen tank explosion. This classification, devoid of narrative or technical specifics, serves as a solemn monument to the inherent dangers of space exploration. It reminds us that behind the celebrated triumphs are moments of extreme crisis, where the boundary between success and tragedy is determined by a single component within a machine of millions. The lack of detail in the source compels us to recognize the importance of the exhaustive investigations and reports that follow such events, for it is in those details that the real lessons are found. Ultimately, the story of any failure is not merely about what broke, but about the knowledge gained from the breakage. This document firmly establishes the what, but leaves the why and the how to be explored elsewhere. It forces us to contemplate the nature of risk and the immense responsibility borne by those who design and fly these complex machines. What do you believe is the most critical lesson for future space explorers to take from a past disaster, even one they may only know by its official classification? Share your perspective in the comments below. Thanks for watching. If you enjoyed this, please like and subscribe for more engineering history.